Alright guys, today I'm not going to be here, so we're going to try to use the ability to make a video to make sure that you guys can do the assignment today. What we're going to be doing is looking at adding and subtracting polynomials. Um, this should be a pretty easy assignment for us. Adding and subtracting polynomials should be the equivalent of uh, simplifying. All we're going to do is mountaintops, which is our distributive property, and we're going to combine like terms, which is our boxing and circling. This is going to be uh, simply a little bit more complex than what we're used to, but in the end, all it should be is mountaintops, and many times there won't even be mountaintops, and combining like terms. If you remember when we were looking at exponents, we talked about PEMDAS. So over on the right, I'm going to put PEMDAS. And we talked about how multiplying and dividing were together and adding and subtracting were together. That whenever we had exponents and we had exponent to an exponent, we always dropped a level and we would multiply. Then whenever we were multiplying, we would always drop a level and we were add. Well, now we've got addition, and we're going to be dropping a level, and there's nothing there. We can't do anything with exponents whenever we are adding and subtracting, which is why you can only combine like terms. We can only combine things that have the exact same variable with the exact same exponents. So that's what we're going to take a look at real quick. There are some problems on here today that the way they're written are a little bit confusing. So we're going to kind of go over those as well. If need be, you can always rewind this and play it back so that you can try to understand it better while you're doing your worksheet. Now, there are only 4 problems on the worksheet today that deal with this stuff. Everything else should be reviewed, so we should do pretty well today. So, just like I was saying, there it is. When adding or subtracting polynomials, you can only combine like terms. So just what we were saying with the PEMDAS there a second ago, whenever you're adding and subtracting, you can only combine the terms that are exactly alike. So taking a look at this problem now, it says to add the polynomials, negative 7x squared plus 4x minus 13 and 2x squared plus 8x plus 7. Well, going back to boxing and circling, my negative 7x squared is like terms with 2x squared. They're like terms because both have x's, both squared. They are not like terms with 4x or 8x. So I can combine negative 7x squared and 2x squared to get negative 5x squared. Then I can combine my 4x with my 8x because both of those have x's in just one of them. So 4x plus 8x would be 12 plus 12x. And then last, negative 13 plus 7. So I can combine those two to make negative 6. Oops, and I forgot my x right there. So that should be negative 5x squared, and then plus 12x, and then minus 6. Now, we can't combine anything else, so this is my final answer. It shouldn't be terribly hard today, especially whenever you're adding. You just have to make sure that you're combining your like terms. This is what we've been doing since September, combining like terms. You will see some mountaintops distributed property here in just a second, but really it's just the same thing that we've done since September, just a little bit more complex. So if we take a look at another problem here, we have parentheses. Now when it says to add and there's nothing in front of these this set of parentheses right here, technically there's an understood 1. Well, multiplying everything by 1 wouldn't change anything. So we don't have to worry about doing the distributive property on this particular problem. We just have to combine like terms. Now, one of the things I notice is that this problem is not in order. We always go in order from the largest exponent down to the smallest or to no exponents. Here, this starts off with x to the third. So whenever we work this problem, we're going to want to work the largest exponent first. Also, to be careful, a lot of people want to combine the first one in this set of parentheses with the first one in this set of parentheses. But if you take a close look, the first one in the second set is to the fourth power. I cannot combine that with 8x to the third. However, we can combine it with anything that does have an exponent to the fourth power. So I can combine my 6x to the fourth, my negative 3x to the fourth, and my negative 5x to the fourth. So 6x to the fourth minus 3x to the fourth would be 3x to the fourth. And 3x to the fourth minus 5x to the fourth would be negative 2x to the fourth. So when I combine those, and I'm combining those first because they have the largest exponent, I get negative 2x to the fourth. Now I go back and I look at my 8x to the third because that has the next highest exponent. As I look through this problem, I don't see any other terms that have x to the third, so I just bring that down, plus 8x to the third. And then last, I can take a look at my constants. We have negative 3 and negative 2, and that gives me negative 5, and that would go last. So I can't combine any of those. This is my final answer. Okay, we're also going to be subtracting. Now, same type of problem, but with subtraction. Now, with subtraction, once again, there is an understood 1 right here. On the last one, when it was a positive 1, multiplying by a positive 1 wouldn't change anything, so we didn't have to do anything. Whenever there's a minus, and that's a negative 1, that would change stuff. So we have to do mountaintops here. Now, one of the important things is we have to do mountaintops, or our distributive property, to every term. So I'm going to have 1, 2, 3 mountaintops that I'm going to be doing negative 1 times whenever I do this. I'm going to go ahead and bring down my 9x to the third minus 4x squared plus 3x. And then when we do our mountaintops right here, we're going to get negative 6x to the third minus plus, and the reason why it's plus is because we have a negative 1 times a negative 4x squared. So that would give me plus 4x squared. And then negative 1 times 2x would give me plus 2x. Now, once we've done that, now it's just a matter of combining your like terms. So we can combine our 9 3x with negative 6. Let me say that again. It's 9x to the third with our negative 6x to the third, and that would give me 3x to the third. We have our negative 4x squared with the positive 4x squared, and negative 4 and positive 4 just cancel out. So the entire thing just cancels out and is now gone. We no longer have any x to the seconds. And hopefully I said that right. It was negative 4x to the second power and positive 4x to the second power, and they both canceled out. And we have last is our 3x plus 2x, which would give me plus 5x. I cannot combine 3x to the third or 5x, so this is my final answer. And then our last problem says to subtract, and this didn't come out right. It says to subtract 3x to the third minus 6x squared plus 9x from negative 4x to the third plus 3x squared minus 5x. So what is different about this problem is it says to subtract this right here from this. Now, the way that this is stated by saying to subtract the first one right here from the second one, they actually want the second one to go first. And let me go ahead and write the second one first. So they actually want this to go first, 4x to the third plus 3x squared minus 5x. And they want us to subtract, and when I do that, I need to put this in parentheses. So this first part right here, we're going to subtract this from the second one. The second one actually goes first, and we're subtracting. So we're going to put this in parentheses because we're subtracting the whole thing. 3x to the third minus 6x squared plus 9x. Now, once again, just like the last problem, because I've got minus and then parentheses, there's an understood 1. So I'm going to have to distribute all of this. And I'll rewrite this, and we get negative 4x to the third plus 3x squared minus 5x. And then when we do our distributive property, we get negative 3x to the third. Negative 1 times negative 6 is positive 6x squared. And negative 1 times positive 9 is negative 9x. Now we can combine our like terms. So negative 4x to the third and negative 3x to the third would give me negative 7x to the third. And then negative 3x squared and positive 3x squared and a positive 6x squared will give me a positive 9x squared. And then negative 5x and negative 9x will give me a negative 14x. None of those can combine, so this is my final answer. Once again, I want you to notice that all of our final answers are pretty big. You are not solving for x for any of these problems. You're just simply doing mountaintops, which is our distributive property, and then combining like terms. Once you do that, then you're finished. You need to make sure today that whenever you do your work, that you get it done. Either get help from a friend.
Mr. McCall, please call the attendance office. Mr. McCall, please call the attendance office.
McCall doesn't need to worry about calling the attendance office again. But either get help from a friend. I don't mind if you work in groups quietly. However, if you are not working in groups, then the substitute's going to have you work on your own just quietly. But you need to make sure that you are getting your work done. Remember, we only have 2 weeks left, and then I no longer take any late work. So if you completely waste today, tomorrow we have more notes. We have another assignment. I expect you to get this stuff done today.